Okay, we're going to do this drill where we review domain, range, zeros, period, and even and odd for sine, cosine, or tangent. You can look at these graphs, but I'm going to show you some of the things that I do to try to start memorizing the graphs, if you will. So I'm going to start by doing a little sketch, and our graphs always go from -1 to 1, and then I divide it into the four corners, which would be pi over 2, pi, 3 pi over 2, and 2 pi. Now for sine, I know that I start at the origin, and then I go up and come back down, and it's the four corners where I hit each of these marks. So then I come back to here, and these are the only places I'm either going to be at the origin, it's 0 or 1 or -1. And of course this does continue going on and on, but I'm just kind of sketching this curve just to help me answer these couple of questions. So the domain, since this keeps going forever and ever in both directions on the x-axis, the domain is all reals. I can see that my range goes from -1 to +1. The zeros are here at 0, pi, and 2 pi, and then 3 pi, 4 pi, 5 pi. So that's the integer multiples of pi. That's not spelled like that. What am I doing? The period takes 2 pi in order to have a full sine curve. Even, odd, or neither, this would be rotation symmetric around the origin, so that is odd. Then when I go to draw my cosine curve, set my graph up the same way, going from -1 to 1, divide my graph into the four corners, which are pi over 2, pi, 3 pi over 2, and 2 pi. And for this, for the cosine curve, I remember that I start up here at 1. And then I make that giant U. So then when I go to answer these questions, the domain, since again it continues forever and ever in both directions, left and right, that's all reals for the x-axis, because domain, is x. Range, again, just goes from -1 to +1. Here I hit the x-axis. My zeros are at 1/2 pi, 3/2 pi, then it would be 5/2 pi, 7/2 pi. That's the odd multiples, plus 1, 3, 5, 7, 9, etc., of pi over 2. Period, it takes one full rotation on the unit circle, which is 2 pi, in order to do a full cosine curve. And this one, if we reflected it over the y-axis, would be symmetric, so this one is even. And then for my tangent, I'll sketch my graph here. And again, I'll do pi over 2, pi, 3 pi over 2, and 2 pi. Now for this one, I remember that I have asymptotes, because whenever I divide by 0, and if you think about the unit circle, this ordered pair is 0, 1, this ordered pair is 0, -1. You're always going to get a tangent that's undefined because you're taking 1 divided by 0 or negative 1 divided by 0. At the top and bottom of the unit circle, which are all my pi over 2's. So that's where my asymptotes are going to be. And then I remember that I have those curves that look like this in between. So my domain is x cannot equal, look where the asymptotes are, odd multiples of pi over 2. The range, this goes on and on as far as the range. This is going to be all reals because it goes up forever and down forever. The zeros, it hits here at 0, pi, 2 pi, 3 pi, all my integer multiples of pi, just like my sine. The period, it only takes pi in order to have a full period. You look at, this is one full tangent curve from 1/2 pi to 3/2 pi. This distance is 1 full pi. And because of the way this curve, this kind of looks like our cubic curve did, this is therefore odd as well. Finding the exact values. This is meant to be a practice page. You're really meant to try and do this without looking at the unit circle. Your completed one. If you want to fill out a newly completed one and do it, you could do that. The whole idea is that you do need to memorize the unit circle. And so I'm going to show you how I would do this in helping myself to memorize the unit circle. I always start off by drawing my unit circle with my 4 corners. And I know that these are my ordered pairs because remember, this is the origin. So I'm 1 unit over and 0 up. I'm no units over and 1 up. So this is just the origin on the coordinate plane, and that's where those ordered pairs are. And I know that this is 0, and this is pi over 2, pi, 3 pi over 2, and 2 pi. Then I think to myself, all I really need is quadrant 1, because quadrant 1 helps me to know what all of my other quadrants are. So I'm going to have my pi over 6 family right here. And then all my subsequent ones would have the same ordered pair, but would be a slightly, it's going to, well, the order pair is going to change some. Let's talk about that in just a second. So we have square root of 3 over 2, 1/2. And then this is my positive, positive, positive quadrant. This is my negative, positive, negative quadrant, meaning sine, cosine, sine, tangent. This is my negative, negative, positive quadrant. I'm going to circle the tangent. And then this is my positive, negative, negative quadrant. And again, I'm just doing this by xy, 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 xy. That's how I get that. Which means this ordered pair is going to change based on these, but I don't need to fill them all in. I do know that this is pi over 6, 1/6 pi, so this is my 5/6 pi. Here I add numerator and denominator, and I get 7/6 pi. And here I add numerator and denominator and get 11/6 pi. Now, I don't usually fill all these in. I usually just do the pi over 6. And I know that this is 5/6. This must be 7/6. This must be 11/6. Then I have my pi over 4 family. running out of a little room here. I'm going to have to put the pi over 4 here. And I like this one. This was the easier one for me. Square root of 2 over 2, square root of 2 over 2. I can even put my tangent out here, which is 1. I could even put my tangent out here, which is square root of 3 over 3. And then this is my pi over 3 family, which is the inverse of my pi over 6 family. So it's 1/2 square root of 3 over 2, and this is simply the square root of 3. So if I just know the 4 corners and the first quadrant, I can really figure out the rest. So for instance, number 1 says the sine of 4 pi over 3. Okay, so I'm in my pi over 3 family. That means I'm going to be dealing with this family here. And it's the sine, which is the y coordinate. I know the answer is the square root of 3 over 2. I just have to figure out if it's positive or negative. Well, this is 1 pi over 3. So directly across from it down here would be 4 pi over 3. Remember, you add numerator and denominator when you go diagonal, because you're adding a pi. So this is 4 pi over 3. So it's going to be in this quadrant. So it's going to be negative. So it's negative the square root of 3 over 2. So I need to figure out the number and the sign. Determine the number by determining which I call it family, and then determine the sign by the quadrant. So there's 2 parts. Okay, let's go to the next one. Cosine of negative 5 pi over 3. I'm still in my pi over 3 family. Now I'm cosine, so I know that the number part has to be a half. I know that part. But I've got to figure out where negative 5 pi over 3 is. All right, this is 1/3 pi. This would be 2/3 pi over here then, because these two together should add up to a pi, which means 5/3 is in this quadrant. However, it says negative 5/3. So rather than, remember when it's the opposite sign, it goes above and below. So negative 5/3 would be up here in quadrant 1, where everything is positive. So this is a positive 1/2. The reason I put that plus sign is to let myself know that I did make sure I have the correct sign. All right, I'm just going to do a handful more of these, and then I'm going to let you do the rest on your own. All right, tangent of 11 pi over 6. So 11 pi over 6 is part of the pi over 6 family. Tangent is got to be square root of 3 over 3. I know that part. That's the number part. Now I have to figure out the sign. Where is 11 pi over 6? This is 1 pi over 6. This is 5 pi over 6. Diagonally would be 11 pi over 6. So I'm in this quadrant where tangent is negative. All right. Cosine of pi over 2. All right, pi over 2, well, I know it's right up here. That's where pi over 2 is. The cosine is the x-coordinate, so that is simply 0. Let's try some more challenging ones. How about negative pi over 6? Let's try this. So I'm in the pi over 6 family, and I want sine. In my pi over 6 family, the sine, which is the y-coordinate, is a half. Now I have to figure out the sign. Well, if pi over 6 is here, negative pi over 6 is here. And my y-coordinate is negative, so this is a negative 1/2. All right, let's skip down here to, let's do 13 pi over 4. The tangent of 13 pi over 4, this is my pi over 4 family and the tangent. So I go up here to my circle. My pi over 4 family, the tangent is 1. So I know that the number part is 1. I need to figure out where 13 pi over 4 is. Well, 4 goes into 13 how many times? goes in.